This is the Average Guy Network, and you have found Cyber Frontiers show number 16, recorded on January 5th, 2014. Here on Cyber Frontiers, we explore cybersecurity, big data, and the technologies that are shaping the future, all from an academic perspective. I'm your host, Jim Collison, broadcasting live from the AverageGuy.tv studios here in Bellevue, Nebraska. Frigid, very cold. I don't think it's going to get above 10 degrees tonight. Bellevue, Nebraska, and we post a show with the world-class show notes out at the AverageGuy.tv. If you have questions, comments, and contributions, of course, you can contact us. Love to have you send us those emails. Jim at theaverageguy.tv. You can track me down on Twitter at jcollison. And now call in those questions, 402-478-8450, and we'll play those questions right here. Love to see if you guys could stump either one of these guys. So send us your questions, and we'd love to answer those right here on the show. And now Cyber Frontiers is a part of the Geeks Network. Find the link to this show and many other podcasts, pretty good podcasts as well, out at the Geeks Network. That's just thegeeksnetwork.com. And joining me tonight from their confines in all kinds of different places, Christian, I really don't know where you're at. Welcome to Cyber Frontiers. How are you? And don't forget to turn your mute off.
Thanks.
What a
You caught me completely off guard. I'm doing fine. Life is good.
Good.
Back in the state of Maryland, where we like it, and all is going well.
Good to have you back. And then Ashton has not made his way back to Maryland. School doesn't start for another couple weeks, so he's still home. Ashton, how are you?
Doing well in the great state of New Jersey. So hanging out in the armpit of America for another month.
Hey, they call it the Garden State.
The Garden State. That's nicer. That's nicer than...
It is. I spent some time in New Jersey, and with last show, I was stationed at Fort Dix, New Jersey, which is kind of down south, and it's about the middle of the state. I just remember a lot of sand when I was there. So I had a good time in New Jersey when I was not really. Just saying, not really. Well, guys, we made it through Christmas. We made it through New Year. We're in 2015. Both of you guys, we're looking forward to school. I'm sure you're not, but we are looking forward to school starting again so that you guys are learning a whole bunch more stuff. But we've got some stuff, maybe a quicker show today. I guess it depends on what we want to cover. Christian, let me throw it over to you, and you can guide us through what we're going to talk about tonight.
Sure. So we're getting more into the nuts and bolts of one of the Hadoop projects that we talked about a while ago that we were going to do on the research platform. And that was essentially how would one go about mapping and learning about the entire IPv4 internet address space using a Hadoop sandbox, the one that we built and covered a couple of shows back. So Ash and I have started to make some progress on this. So we're going to talk a little bit about what tools we're using to implement this and what kind of some of the groundwork operations that he and I are both doing along these lines, and what types of outcomes are potential and what types of things are going to be we need to additionally develop in order to get to this place. So with that, I actually start with Ashton, who is putting the groundwork in on the part one of how one goes about this.
Yeah, so this really is based off of the program called Nmap, which is a network scanning software that lets you have an idea of the different services that are running on ports, and potentially also the operating system. And at a more granular level, you can even figure out, is there a HTTP server running there? Is there SSH open? Things like that. So it's often used by attackers. It can be used by attackers to figure out if there's vulnerabilities, but we're going to be using it for the more benign purpose of just getting an idea of what hosts are up, and also hopefully figuring out the routes to get there. So the reason why it piqued our interest is there's a graphical interface for Nmap called Nmap, which I think Christian has a little simulation running, which we'll show you in a little bit. But what it does is it comes up, Nmap is typically run from the command line, but Nmap is the graphical side. You can see some of these graphs that are created from scanning these ports. And the cool thing about that is you get an idea of how the networks are laid out based on this, and you can click on the nodes and it'll recalibrate it based on that. So it gives you a better idea of the graph, in not the graphical in the sense that it's like a picture, but the graphical in the sense that it's connected nodes, and you get an idea based on that. So that's what we want to do on a much grander scale. We've talked in the past, it's been done a million times, scanning all of the IPv4 network space. And while this is not so difficult if you're just interested in seeing if the hosts are up and if a specific port is open, this becomes more complicated if you're also trying to find the trace routes along the way. So you're trying to find the physical layout of it and the graph layout of it, and then do interesting things with that. So the end goal for us is hopefully to have something where you can query a specific IP address and see all of the adjacent nodes on the network to maybe 5 degrees of separation from it. And I just think that would lead to some powerful insights about what networks have a lot of the power and have the most connections in terms of adjacent nodes. So it should be an interesting project, and it's kind of necessary for us to go out and get the data ourselves, because we don't have a data set that we can just use, since we're not affiliated with a company that's bringing in a lot of this. So it's an interesting project from start to finish, and I'm looking forward to getting started on it. So I've already looked into something called distributed Nmap, which is another of the family of the Nmap programs. And what that is it lets you run Nmap from multiple nodes, so multiple computers, let's say, and have all of the results of that sent back to one server. So we already have the Hadoop sandbox set up, which is our little cluster for distributed computing, and I figured we might as well set that up there. So that's what I spent a good portion of today doing. And hopefully I can feed that data back into the Hadoop cluster, and we can use that as our data processing warehouse there. So that's pretty much where we're at now. And it'll be interesting to see how feasible it is to essentially run trace routes to every IP address, because these are really time-consuming operations, as Christian's found out already.
Yeah, and part of that too, I think, is the DNS that it does, because it's not just measuring the hop. I think for each IP, when it stops at the next hop, it runs a DNS query, and each so if let's say you're loading google.com and you're sitting, like, let's just say 20 servers away to get to Google, then you're doing 20 DNS queries. So that's what's taking up your time. So technically, we might be able to get that time down by not doing authoritative.
Maybe caching the previous results or something like that.
Yeah.
Not doing the DNS queries every single time.
Right, or doing the DNS lookups after the fact, maybe, and not using it to build the map. So there's a variety of things that you can do, but yeah, your standard, I'm going to run a traceroute command in Linux or in Windows or what have you, that will by default do DNS resolution at each hop, and so, it's more or less a convenient tool when you're trying to debug things like, is this maybe appearing, like, say a site is down for you and it's up for other people. Well, maybe that's because one of the peering partners in which you get your internet through, something along that trace route is dead, and your computer wasn't able to find another way, another route to get around it and find a path to the server. So, trace routes have characteristically been pretty successful debugging tools, but I don't think anyone has really ever tried to use it to map out the whole internet in an intuitive way, at least. So one of the goals that I think is interesting is, when we originally started talking about this project, we were talking about scanning all of the IPv4 address space and just doing like a really basic thing. Like, let's say we check at each IP address to see if port 80 is up, right? And this may or may not be a fast way to like know IP addresses that are actually alive, serving content, making up a part of the internet, right? But with the trace route, you get a lot of data because you're getting a bunch of intermediate servers of how you get there, and that in and of itself is helping you map things, right? So originally, when you think, well, how would someone go about scanning the whole internet? You would probably just characteristically, break up the entire internet subnets into chunks and have multiple threads be responsible for each chunk. But traceroute is actually interesting because, you're basically picking little pieces of the pie in random subnets at any given time. So what would actually be really cool is to build some kind of metadata manager, some kind of state manager that says which IPs have already been visited in that subnet and when that subnet is 100% visited. And the way you visit 100% of the subnet is by doing as many trace routes as you can at first before having to basically directly, ping a port 80 on an IP and see if it's there. So that's one cool thing about doing the trace route. The other cool thing about doing the trace route that you really don't get when you're just doing a distributed IPv4 scan like we were suggesting, is you don't understand how the internet is connected, how the internet's a living, breathing thing. And really, this gets us into a pretty cool topic in, computer science that many people have gotten PhDs based on a derivative of theme, which is graph theory. And how does one, from applying data structures to, implementing them, graph theory has an incredibly large domain that spans from everything of neural networks and artificial intelligence to how we describe physical networks. So this is a really unique opportunity to say, well, how do you use big data tools to build a huge graph basically of millions of nodes and arguably millions by millions of connections or edges to those nodes? What does that look like? How would one build it? And so, Ashton and I, one of the things we struggled with when we originally implemented it, I don't remember what we were thinking that was giving us the roadblock about mapping it, but we always wanted to have a visual component to the project, and we weren't really thinking trace routes, and I can't quite remember why. But eventually what you start to realize is, the more trace routes you run to various or different hosts, eventually you're going to discover and see that, hey, when I queried 2 different websites, I got up to a certain point where I was going through the same traces, or hey, maybe it gets all the way to the last one before the final destination, and there's other sites that I had previously connected that, are connected to that node. And so you can really do some pretty interesting things. Now, the only kind of natural problem with this approach is that by default, the data set will be biased to wherever you build the trace route from, right? So if let's say I'm doing this crazy distributive project on a cluster of servers that all sit in one particular network, well, that one particular network has its own interesting, unique way to get out to the internet, and it might hit different websites using different routes depending on how the system architecture is designed, and that may not necessarily be the case for traffic coming back, right? So if I were to do this out of a data center in Utah and build a world data set, it would look different than if I were to build this world data set out of New Jersey and do the same thing, right? So one interesting aspect to this is that you can't really build a data set that is going to look the same across, in terms of reproducibility of this worldwide internet network. It's not necessarily possible nor feasible that everyone's network of the internet is going to look identically the same. But I'm just going to give you a little glimpse of what one might look like at a very small scale, and then kind of give you an idea of how one goes about, broadening this to the masses. So is my screen share on?
It's coming. There it is.
All right. So this is the Nmap tool. This is really a Windows graphical interface on top of the Nmap tool, which is widely popular in the Linux cybersecurity community. And so what you see here is the dots in green. They're just, I put in a couple sample host names, right? So, Yahoo, CNN, Fox News, NBC News, Google.com. I tried to pick all 3 major newses from left to right so I didn't look biased, but I didn't get time to do many of these. And what you noticed is basically I'm localhost, right? So I'm the guy in black. So if I click my black dot, it's going to center all these websites around me being in the center, and these websites being the sites I'm going to, right? So the rings that are going around, think of them almost like tree rings that you would see if you sliced a tree horizontally and looked at the rings. And each ring apart is a unit distance away from you in the center, right? It's kind of like a sonar map in that way. And what you can notice is that, from my local host, I'm always going out of 2 or 3 of the same servers, and then I take some different pathways to get to my final destination. But notice how, there's 2 websites that get all the way up to level 3 communications, which is a big internet provider on the East Coast. They're pretty much part of the internet backbone all along the Eastern Seaboard, right? Notice how if I go to CNN or Yahoo, my traffic is routed through L3 communications, right? And so if I click that dot for L3, now I can see what it would look like if I'm sitting at the center of L3. What are all the different routes, right? But I want to go back to what it looks like if I'm at localhost, right? And again, if I'm at localhost, now turned them all around, but look north. Notice that level 3, if you follow this line up, you see that level 3 is right here, the edge for level 3, and that takes me to yahoo.com and cnn.com at the end of the day, right? But notice how if I want to go to something like Yahoo, it never goes through the L3 network. It goes through the Quest network and then comes out through foxnews.com. If I want to go to NBC News, it goes through the Comcast network. And so we see it coming out of the state of Maryland in through Northern Virginia and out to a server that looks like it's in Colorado, of all places, serving me NBCnews.com. So it kind of gives you a very basic example of the internet being a living, breathing thing, meaning that, how could one go about blacking out parts of the internet? Well, think about it for a minute. What happened with, this is a little bit of tie back to our conversation about North Korea a couple weeks ago. We said that North Korea only has 4 routers that connect you to the internet if you're coming out of North Korea, right? So in that map I just showed you, there are only 4 dots that take you to all those different websites on the outer ring. Whereas in the United States, there's 150,000 of those dots that I could potentially map and put on my board, right? So if I'm North Korea, it's, I know if I take out these 4 nodes, then North Korea can't get to the internet, and people who are trying to get content in North Korea won't be able to get it. Well, I think people somehow were able to understand this when we were talking about 4 routers in North Korea. The public got it, and the average guy got it, whether or not they were technical. But in general, I don't think people really understand that is also a very true, living, possible thing in the United States. We've had definitely documented cases of, congested traffic and pipes, or, certain parts of that backbone infrastructure that go out and have outages. And you're sitting here wondering, why is my page loading slow? Or, I have this great bandwidth package at home, but I can't, this page is just taking forever. Why is that? Well, it's probably because one of those particular nodes that's usually the fastest way for you to get out is either down or congested or not answering your request. And so your computer is then backtracking and say, ooh, I got to find another road. It's just like, it's the same thing as traveling salesperson in graph theory, or, for the average guy, it's the same thing as how many different ways can I drive from Buffalo to Boca? There's maybe 3 different interstate highways. One of them has construction. One of them has a car accident. And so you take the third one because it's the scenic route and it has no traffic. And, if you speed a little bit, you're going to get there the fastest. So it's kind of the same thing. It is the same thing with the internet. And
wait a minute, Christian. That sounds like you've done that recently.
No. Me, never. I would never do that. And so what you know, it's interesting because I feel like this is a big cyber research area in the way that, you know, I don't think anyone really has a grip on. No, there's no one particular person that could, you know, rattle off their top of their heads, you know, oh, I'm sitting in this Maryland network. What are all the different servers and major providers that are going to serve yahoo.com up for me? I mean, you don't know that, right? So one of the cool projects we thought that we would readapt this to is using a distributed Nmap to do the distributed trace routing and basically build this whole database from our perspective and our machines, and then, you know, use graph theory and the data set coming out of Hadoop to basically make it indexed and queryable. So I could then type into a search box, you know, tell me all of the websites and all the services that go through this host or this relay or this IP address. And I could just type in a IP address and a host name, and it would tell me everything it knew about it based on those graphs. And typically we couldn't do something like this on a regular computer because of the size of the data, right? This is just a query we cannot return with a regular system. So it definitely is an architecture challenge because the quantity of the scale that is required of putting all these different nodes and edges together is very significant. So the challenge here is not just kind of the can you figure out what's going on the internet, but can you really build and architect both a data set and a front-end graphical interface that can handle this volume of nodes and edges? And, you know, I think the scalability of graph theory is, you know, then you start getting into things like, what does Dijkstra's search algorithm look like on a Hadoop cluster? And these are the kinds of researchy questions that students make master's degrees and PhDs out of if they're curious. So,
yeah, and we need to be clever also, not just, I mean, the data is big, but the other problem is if these take a second each, it's like, okay, that's pretty good, and that's probably fast at what you're getting right now, then this will take forever. It will not literally forever, but like I would guess in the tens of years range, because if there are, what, 40 million IP addresses or something like that, I'm pretty sure it's on that magnitude, then, you know, that's, I think that's on the scale right there. The problem then becomes, can you do this in a way where you're leveraging not only the distributed nature of our cluster, but also can you not have to retraverse the graph every time you want to get to a point, and do that in a way that, you know, maybe if you're going along, you know, points 1, 2, and 3, and those are common among all of your requests, then you don't need to do the DNS lookups for those every time, or you don't need to necessarily retraverse that and try and figure out where you're going every single time. And if you can make use of where you know where the subnets are, you might be able to do it orders of magnitude faster. And that, I mean, that could be the difference between finishing this or not. I'm curious to see how feasible this is in terms of time and not just space, because I think that we can do it for space is less of a it's less constricting than time even in some cases.
So when do you guys plan to kick off the query that starts it?
I mean,
or the crawler? What I mean, how? And let me ask you this: how different is this than what Google's problem is with web crawling?
Well, they're looking at search engine optimization, and we're a little more concerned with just the hops in between. So it's not necessarily valuable to Google to keep track of adjacent, adjacent websites or adjacent websites and adjacent nodes are a little bit of a different concept to begin with. They're not necessarily separate IP addresses if they're websites. So I'm not sure that what we have would be the same thing as what Google has or what they're concerned with. I'm sorry, your first question slips my mind now.
Just wondering. What did I say? When are you going to kick it off? When do you think you'll start this?
I'm not sure, but the thing that we have to think about is how we want to store this information. One way that my naive approach would be is to just store the adjacent nodes for each node, which is like an adjacency list, if you've ever done graph theory, which is what I just had for a class, so that's my bias towards it. I'm trying to think if there's a more efficient way so we don't have to duplicate all of those nodes that would show up multiple times. Um, so we could start like tonight, but it wouldn't. I don't think that we would come up. We might have to start over again, which is not what you want to do. So it depends on how long it takes us to figure out the structure of the database and the structure of the data that we're going to insert into it.
Yeah, and I think the other thing too is a fair amount of the design challenges are right up front, right? Not even before you get to the graphical front end, just figuring out how you're going to build these distributed crawlers that are efficient about trace routing. You get into those issues of when does it make sense to do a DNS query here? When does it make sense to hold off? Ash and I have been going back and forth about what is the most optimal way to store this data in HDFS that takes up the least amount of space and lets you analyze the data as quickly as possible. And we've talked about everything from JSON files to compressed ASCII text to, you name it. So building something, the graphing algorithms and all that stuff is all well and good and is very well documented, but how does this particular data set need to be stored smartly is a huge question that, you have to answer hopefully right the first or second time so that you're not making more work for yourself in the long run.
Yeah, and because of the way that we're doing it, it's going to end up not just as a graph, but as a specific type of graph that's really a tree because it's all from the same source. So there's not like, the distinction there is each node only goes to a node level deeper than itself. So it's not like there's connections on the same level. We're not running a trace route from each of those hosts really. It's just like a point on the way to another point. So it'll be interesting to see if we can take advantage of that so that we can store it more efficiently.
Yeah, and I think that by and large, there's probably multiple successful ways to actually do the storage of this particular data set. A significant challenge is actually knowing whether or not one method is particularly better than the other, because you could get to the end of it where it's like, okay, now I'm actually searching the IP from this front-end graphical interface, and the response times are very similar between when I store it this way and store it this way. Is it faster in one part of the algorithm and slower in another, or is it just that my data sets are both comparable? Those are all things that you kind of have to test in isolated cases one at a time to really figure out where your performance enhancements and bottlenecks actually are.
Yeah, and I think we'll get some interesting data that's not necessarily related to the graphs at all as well. Just the results of the domain names would be interesting. For example, there's been a lot of I've read a couple studies on how you can have a pretty good idea of whether a domain is malicious or benign just based on the name of it, using different metrics about where it's located, the length of it, some of the words used. So if we could inject some blacklisted DNS into the results that we get and compare the two, we might come up with some interesting results there. And that's just one application of this. So I'm crazy about good data sets, and I see this as like the mother of all of them, just having that full IPv4 network being scanned. So I'm pretty excited about that. I just hope that we can do it in a way that it's useful and time efficient.
So remind us again of the box that will do this physical work. How much storage? Just give an idea of in either one of you, when we think, if the average guy think from a PC perspective, how and I know you haven't projected yet, but what do you have that it's going into right now?
It's not super huge, but it should serve our up to what we need. It's an HDFS cluster, which is the distributed file system for Hadoop, and I think we have 3 terabytes right now, but it should be easy. I know right now the 3 terabyte drives are really cheap, so we're thinking of picking up a couple of those. But for starters, we have 3 1 terabyte drives, and the data is replicated once, so anything that we would lose on one of them would be copied on the other 2. So it's not necessarily hard to grasp if you've already worked with 1 terabyte drives, But considering that the type of data is important, like storing a movie is a lot different than storing, or let's say it's a 30 gigabyte movie is a lot different than 30 gigabytes of text. 30 gigabytes of text could have taken lifetimes of 100 people writing all the time to fill up, and not even. Whereas a 30 gigabyte movie might only be an hour and a half. So I think for this particular format, if we're only storing 20 bytes for an IP, which is minuscule, then you have to imagine that we can fit many millions more than we even need to.
I think the analogy here is how granular is your data set, meaning you can have two data sets that are both, let's say, 30 gigabytes, but depending on how granular the data set is depends on how large not the quantity, because they're both 30 gigabytes, but the density, really. It's the density of your data set. It sounds bizarre, but
how much information did you get?
Think of it, it's the same thing as a computer monitor, right? You can have two monitors that are both 30-inch monitors, but one might be 1920 by 1080 resolution, and one only might be 720p resolution. So you can have the same physical dimensions, but one gives you a better picture in HD and one gives you a standard def picture. So that's the same thing with these data sets, right? Going back to like a movie, or let's say like a database of images, right? The text of all these fine points may describe a longer period of time than just this one image that takes up the same amount of space. But that's because in this particular case, I'm thinking about the image as being that flat two-dimensional panel. But if I think about it in that next kind of third density dimension, so to speak, what if I'm thinking about the image in terms of each individual pixel, and maybe there's something in each of those pixels that is telling me something that I need to know about. Then all of a sudden your data set has more density than what you originally assigned it. The example I always give is CAT scans, right? When NASA does what's called non-destructive evaluations and techniques, there's a whole branch of mechanical engineering dedicated to NDE, which basically is how can you kind of forecast failures in a mechanical physical structure using these CAT scan volumes. So obviously, there's destructive testing where you test something until it breaks, but there's non-destructive testing where you don't want this thing to break. It's maybe it's a wing on a production, or not, wow, I sound like a computer scientist. Maybe it is a wing on a real flying aircraft, and you want to know, is this thing still structurally sound? Well, what you'll do is you'll end up taking a 3D CAT scan or volume image of what's going on in this wing, and all of a sudden now in 3 dimensions you're looking at each of those pixels, and typically a scientist will look at these volumes and they'll look for where the microfracture occurs, what type of fracture it is, what this means in terms of the material that's being used, and so forth. Now imagine that you're trying to get a computer to use AI or machine learning to look at the pixels, and based on the averages of color values in certain places tell you whether or not there's a microfracture buried somewhere in this huge CAT scan volume that normally scientists are sitting there calling through layer by layer looking for where this microfracture is. That's the difference. So density is always relative, which is a difference, a distinguishment from when we say, two monitors, both 30 inches, one has 720p, one has 1080p. That's always the same. You're never going to change that. But when you're doing data science in these projects, the density is relative to the project and the goals of what you're trying to find, and based on how fine comb you need it to be to get what the answer you're looking for determines how dense it is. And typically that computation and that density is proportionally scaled, meaning that the more dense your data set, the more your CPU is going to have to work at it. But in terms of what's on the hard drive, it's the same physical space being stored, and it's the same amount of disk speed and read-write speed you're going to need to do the analytics.
Yeah, so we pretty much have the idea laid out there, and I think we now just need to get the structure there. We're looking at interacting instead of directly with the Hadoop distributed file system. We were thinking of using HBase, which I had done a post on the website before, and using that again to store this information. It's a NoSQL database, which is good because the format of the individual trace routes will probably be different each time. There will be different amounts of information and potentially different things for each one. So it gives you a little bit more flexibility there. So that's another thing that we're going to be looking at when we're doing the database restructuring.
Yeah, and actually the cool thing about that too is one of our end goals with the user interface would be to be able to just say, if I type in this IP, construct the graph of all the nearest nodes, let's say in a 5-mile radius. If you're driving on a highway, we'll just make that analogy right now. Give me everything in a 5-mile radius, or if we're going to talk computers, in a 30 millisecond hop radius, right? And that is really conducive to like a SQL query, but obviously this is not SQL data, but Hive gives you that opportunity to basically run these Hadoop HDFS interactions using traditional SQL-like queries that then get translated into, well, traditionally MapReduce, but there's kind of other techniques of doing that now that are just as relevant, I think, in terms of getting better performance, but doing the same thing in the long haul.
Yeah. So, I don't know. I don't have much more to say to this until we do more work on it, but that's kind of the some of the details on how we're thinking of implementing it. Do you have anything else that you want to go over for this?
Yeah, no, I think that's a wrap on this particular project. Like I said, this is kind of the recurring update on what's been going on with this. When we come back in 2 weeks, we're going to talk a lot with a guest from earlier on, maybe show number 4 or 5, Dr. Jim Pertolo, and we're going to get back into some really cool topics that a lot of people loved hearing about the last time. So look forward to that. That's he's a man of many words, and all the words he says are intelligent, whereas mine are only like half the time I get them right. So he's got a lot going on in his head. So always love having him on the show. And I do want to follow up back on the North Korea thing, though, because I still find this fascinating. I still believe this is going to be the one thing in terms of cyber that gets written in the history books for this time period. Like I said, maybe there'll be brief, minute references to the wall or the Home Depot credit cards and all that kind of stuff. But going back to this, I find it fascinating that there seems to still be this ever-growing dynamic between the cybersecurity kind of industry and government saying, yes, North Korea did this, and the cyber professionals being very skeptical and not trusting that. But if you didn't see it in your newsfeed this week, the United States went forward with imposing sanctions on North Korea over this thing. So apparently they're pretty convinced. So it's still, to me, interesting, the facts and cyber forensics that are being used to construct and put those things together. And it's something to keep your eyes peeled for, because there's dynamics taking place here that are, in my opinion, kind of first time on the public eye and radar.
Yeah, I find that hard to believe in some cases. I wonder what information they see that we aren't seeing, because to the casual observer, it doesn't necessarily make sense for North Korea to be connected to this attack beyond the fact that the movie was insulting to their leader. But I feel like there's just not the technical knowledge or firepower there to make this happen. And although, yeah, maybe it was routed through their servers, I feel like these Guardians of Peace activist group are not necessarily directly affiliated with North Korea, and it must have had some sort of internal connection or some sort of social engineering attack that they used to route Sony so thoroughly. So I'm skeptical, to say the least, regarding the accusations towards North Korea, but perhaps they have information that I'm not aware of that condemns North Korea as the perpetrator of them.
It's like so many other things we'll never know. Maybe
Yeah.
20 years from now, we'll actually know the truth. Lots of things about World War II, which was a long time ago, coming out now or in the last 10 years that, of course, we didn't know about. And so who knows? An act of war, I don't think so, but certainly an act of sabotage. And how difficult would it be to necessarily route this through their servers and back out, to make it appear to, I mean, if you're going to be that sophisticated and having an insider, how hard would it be to kind of make it look like it was them? Or how much of an excuse does the United States need to pick on North Korea? So,
Yeah.
could be that as well.
Still, I feel like if this an act of war might have been if they somehow dismantled our critical infrastructure.
Sure.
That or
Come on,
what have
Sony's
already-
a critical infrastructure. There's movies, for God's sakes.
I mean, yeah.
Yep.
Actually, in the long run, it might have benefited us because now it's on the cheap on like YouTube. It's $7 instead of going to the movie theater see it for
Right.
$12. So the American public, unless you had vested interest in Sony or literally investments in Sony, not super affected by it. Again, I've said it before. I'll say it again. Attacking Sony is not the way to bring the American public to its knees. So I feel like if they were serious about an act of cyber war, looks more like something that a group with more limited resources and less experience would pull off with some sort of internal help.
Yeah.
And you have to
Yeah.
imagine that there were disgruntled Sony employees, especially based on the emails that were leaked regarding, oh, this actor, sick of their movies, this isn't working. If Adam Sandler has one more movie, I'm gonna kill myself. It's just things like that make you wonder that maybe one of these people is gonna get let go, and they're like, I'm taking it down with me, and not necessarily North Korea plotting out how to systematically destroy America.
Yeah. Yeah. No, Ashton, I think your assessment is a good one, a good and valid one. We there's we don't have a lot of access to some of the information.
It's
that we
it's all
need.
it's
Yeah.
all just speculation without the hardcore cyber
Yeah.
forensics that they must have access to. And I don't pretend to know what the FBI agents that are doing the analysis on this know, but I'm curious to say the least.
It makes for an interesting case study that I think, to Christian's point, I think we'll be talking about this, whether it was corporate espionage or an act against the country or was from them or through them or they didn't do it at all, but somehow they're being blamed for it. I think it will be a case study that gets looked at for quite a while.
Yeah.
And we'll have a lot of grounds because I think it's interesting enough. It's not so cut and dry that you just go, oh, that's okay. That's it. They stole credit card numbers, and now they're in the hands of Russian hackers, right? It's such a mystery, right?
Yeah.
There's so many things out there that we're still kind of going, well, that doesn't make any sense.
Well,
you know?
it's got a lot of just a lot of appeal from like a story
It
aspect.
is a
like,
movie.
Oh, there was a movie. It is. It should be a movie about
it
how
in
this
itself
movie
is a
was.
movie.
It-
I mean,
there's
what
a lot
if
of-
the joke was on us and this was, right? I mean, you kind of go, and I talked about that last time, right? There's too many things that have happened that would
Yeah.
not be that way, but it does feel like a movie in some ways.
Yeah, but I don't think that from a cyber attack perspective, I mean, it's impressive that their ability to get through to every point, practically, to every database, to the very loosely secured, but still impressive that they were able to do it so aggressively and get to every single one of these things and map them out and just tons and tons of information that was leaked. That's crazy. I would still say this is second to Stuxnet for a lot of reasons, not least because of the way that Stuxnet was executed was meant to be very, very secretive and was not detected for a long time, and I think had a lot more dire impact on.
Well, it was meant to be destructive, right?
Yes. Yeah, and I think it was more successful to that end than this was. But I would say that nothing else comes to mind that was bigger than except Stuxnet that was bigger than this. So I still, and like I said, because of the media appeal, it might be more on the public side than even Stuxnet was at the time. But I'm not sure that the hacker prowess was necessarily quite as high.
Yeah,
That's cool. Anyways.
And it's a little bit different in the sense that Stuxnet was going outbound. This is the first one inbound that I think was this intense.
Well, for Americans, right? Hey,
Yeah.
we're okay with it.
Right.
It's not us. if it was someone hacking the grid, the power grid on the Eastern Seaboard, and it takes down, New York, Washington D.C., and we'll spare New Jersey on this in this example. People are, then it's a big deal, right?
Yeah.
From that standpoint. So I think you're right. We flip these, and it becomes at least in Americans to the American psyche. From that
We had the
standpoint.
easy retaliation too, with only those 4 points to knock out their entire outbound internet.
It wasn't very hard, was it?
That might have been as easy as their, which I assume they had some internal guy, but it might have been even easier than their job.
I know. I mentioned it before. It's hard enough to get information out of Exchange when it's working and you're the admin and you have the passwords.
When you're supposed to be able to access it.
Exactly.
Well, that was just a simple distributed DDoS attack, and I think I have redundancy there, but you get
That's
the
right.
idea.
Yeah. Referring to the next day or recently when North Korea went down for a day or two, from that standpoint. Well, it leads for interesting days that we have, and lots of great stuff to talk about. And we don't pretend to have any inside information here at Cyber Frontiers from that standpoint. All speculation, just on our part, and so interesting looking from the outside, looking in. But fun stuff to talk about for sure.
And hopefully we'll have all of the, well, at least from New Jersey and Maryland, all the hot points to those 4 North Korea servers. And I think that might, tying this back into what we were talking about before, might be an interesting way to approach this, as going country by country and doing the subnets like that, so that we have a good geographical distribution. And I think that's going to also reflect the way that they're physically laid out with those routers. It kind of makes sense that if you're going to go to a domain with that KR domain name, which is Korea, then it's going to follow the same path pretty much every time. So maybe we can leverage that just as an example, so that we don't have to resolve all of those points every single time. So,
yeah. And this is all, you're going to post this all on Cyber Frontiers Labs, right? cyberfrontierslabs.com. You're going to some of the stuff that as you work on this.
Yeah. Which, by the way, let me just mention that Ashton killed it with his last write-up about the sentiment analysis. Got some coverage in the Crazy Works Cybersecurity InfoSec magazine, and got like 100 click-throughs on Twitter in like 5 days, which almost broke my record. Only second to show number 13 on the Exploring Through the Twitterverse, which pulled in 100 followers off Twitter to come listen. So
cool.
Nice work on that, Ashton.
Congrats on that,
Thanks.
Ashton. Yeah, good work.
and thanks to Samantria for their semi-public sentiment analysis. So, I'm glad that people were interested in that.
Some good stuff. If you're a Cyber Frontiers, if you're a regular Cyber Frontiers, even if you're just first time, that cyberfrontierslabs.com is kind of the test bed, so to speak. A lot of the interesting posts go out there. This is where these guys post kind of what they're doing. We, of course, post the show over at theaverageguy.tv, and so if you come across this, sometimes folks are listening to us on, we've distributed this out. In fact, there's one cyber network that we've put this on. And if you're listening to it there, you can come over to theaverageguy.tv. That's the network, and subscribe to the show if you want to get it on a regular basis. If you want to follow along, if you want the show notes and you want to follow along with what these guys are doing, Cyber Frontier, no S, I've said S twice now.
Yeah.
Cyber Frontier Labs, S is at the end.com. We'll get you there. And, of course, all those links will be in the show notes at theaverageguy.tv/CF016. For this show as well. Christian, before we go, you want to talk a little bit about our Maple Groves project and just kind of what we're doing there?
Yeah, so we are now well into the 2015 launch. We talked a little bit. I think there's going to be home tech tips coming out this week about it that goes into some detail.
Maybe even
But
yet tonight.
yeah, so we are now making public the hosting platform that has run websites like The Average Guy and abroad. And whether it's a site that gets 100 hits a day, a casual blog, or a site that gets 22,000 plus hits a day, we're running a wide gamut of those on this platform. And we really have done a lot of work to make this a platform that is reliable, secure, private, isn't tied into things sucking out your data, and is just fast. And the way we do that basically is by taking all that upper level management clutter and cutting it out. A lot of it is my own custom code and configuration, and this has been a project that has really gone on for 4 years in closed beta, right? I mean, the sites like The Average Guy that have been hosted on it, this has been closed. It hasn't been a public offering. So we spent a lot of time working out the kinks, and we now have dedicated hosting with Verizon Fios Business and high-speed fiber optic. And for $10 a month, you can basically come on the platform, get unlimited bandwidth, have a site that runs just as fast as The Average Guy or BiosMods or any other of those websites. And I think the biggest success story to show just how fast and fine-tuned we've gotten the platform is there's this really crazy game called Elite Dangerous that is just one of the most obsessive-compulsive games I think that's out on the market. So there's a website that basically helps people with one of the aspects of the game, and so it's very popular because it's for trading, and it gets like 24,000 hits a day and has about at any given time 300 concurrent users. Pages pop up like nothing. elitetradingtool.co.uk. And so there's just a wide variety of sites that we're running on this. The platform handles it really well, and it's a great way basically to not have to get sucked into the rabbit hole that even I did as a starting out webmaster or blogger. We all go through the same process. We start out paying $8-10 a month at a shared hosting provider like IX Web Hosting, and the support tickets suck, and then you can't once you start getting up to a couple hundred concurrent users or start getting any kind of real traffic, it's slow and the page sits there, and you're like, I got to get off this. So then you go over and you move to a VPS, and then you're paying high-end dollar. You have to do a lot more configuration, and before you know it, you've moved 2 or 3 times before you really find something that you like. With this, everything is really kind of custom curtailed and is based on all the experiences I've had hosting a variety of different websites that have different requirements. I like to think the platform's especially tuned for things like WordPress-based sites, so LAMP stacks, and it's also the platform for podcasters. That $10 a month plan that gets you on the high-speed web container for your website comes with 50 gigabytes of disk storage. And when Jim and I looked up how many podcasts you could store on that, you could store 8 years worth of your audio for podcasts before even having to think about a minor storage upgrade.
Yeah, based on what we do here at theaverageguy.tv. So
right.
we run pretty long podcasts. So
right, and
yeah.
and because of the disk is great, but it's unlimited bandwidth, so it's not like you're gonna have to worry about, I got X number of listeners coming on, am I gonna hit a quota? Which if you're on shared hosting or you're on VPS hosting, they monitor those things pretty closely. So again, we've also set this up as a scaled thing. So the pipe that we have for the platform scales proportionally to how many customers and users are on it, right? So right now it's 50-50 pipe, which really puts out about 65-65 pretty consistently. And as customers come on and we see the pipe getting used up, we proportionally allocate up to a full half gigabyte line, 500 down, 500 up, at which point, if that were to ever get maxed out, we add another line and split in half. So everything is load balanced. There's a load balancer failover and live migration. The databases are backed up on a daily, weekly, monthly basis, so we have images of all of that. Your web container, if it were to ever have a hardware failure or a software failure, is replicated to another environment that syncs every 30 minutes. So at most, unless you've uploaded a change to your web server in the last 30 minutes, your database is obviously going to be live, so you're not going to really see any changes in that department. So, really kind of dynamic failover, rollover environment. And if for some reason the web container isn't high enough performance for you, which, I mean, unless you're something like that elite trading website, I don't know how on earth it could be. You can go up to our dedicated hosting plan for 30-month, which gives you your own dedicated CPU cores, RAM, box, you name it. And those are the types of setups that go for, the $90, $100 a month plans on the internet. But, we've really worked to architect this in such a way that we cut all the overhead prices, the support streamline. I like to think that it's obviously a smaller company than big things like a Bluehost or IX Web Hosting. So you're dealing with humans like me and other fellows. And as this thing scales up and we get people, other smart people from the University of Maryland will be helping with those support tickets and those requests. So it's not like we're going to be shorthanded if you guys support the platform with coming over to it. So
I think it's, Christian, I think that's a fun project. And I mean, if you were thinking about starting a website, or you wanted to bring something, you want to dip your toe in the water, or do a WordPress instance, something along those lines, I think this would be a great opportunity to jump in and do it with people right? If you're in our community. I just got an email from a guy today who signed up for the newsletter. By the way, if you want to jump in on the network newsletter, head out to theaverageguy.tv and get signed up for that. And he had signed up for it, and I sent a note back and why you listen, and he goes, I just love the community. Everybody's just so nice to each other here. And that's not super common among tech communities. You can get wrapped up in some tech communities that little flamers, little trollers that are out there. And this one, we just don't tolerate that kind of stuff. And so if you're doing that kind of stuff, we're gonna boot you for the most part. So it's a great community and a great opportunity to hang out and give this a try. Again, the Average Guy's hosted on it, and it's been fun I went through that evolution with you, right, Christian?
Yep.
We've gone through these steps of the evolution, and I've had a great time doing that. But it's just a great opportunity to jump on this. So if you were thinking about doing this might be the right time. If you're thinking about jumping in on a small business and having fun with us as we kind of run this ride, and Christian's intent, he's learning a lot through the process, as well as the intent there is to give you just the best service possible. See where we can grow this thing. If you'd like to jump in on the ground floor, you can say you were one of the first. Yeah. How many first 25 customers?
Yeah, pretty much
on the platform, right?
And I mean, if you really want to know, well, just how fast is this thing, go to theaverageguy.tv. That's there's your $10 a month web container plan.
Yeah.
Also, keep in mind that shared hosting, one of the biggest pitfalls is they love to overcrowd people on servers, and I always make sure there's a hard cap so that there's no crowding and squeezing out, and people are coming up for air to try and get their website to load a page. So you really get that benefit, and like I say, your data stays secure and private and off the public cloud infrastructure. So if privacy and encryption is a selling point for you, it's on this platform. Even in our administrative infrastructure, we're the people that go the extra mile with cybersecurity. So you're not going to be logging in to your FTP account with a username and password. It's going to be an automatic key that's sent to you that does RSA encryption. So it's a pretty unique infrastructure that is very unlike any type of web container you're going to buy on the internet for that kind of price.
Yeah, I think that's the point, is that it's not like this isn't just your shared host provider at one of these big companies. Yeah. And so great opportunity. Christian mentioned, although he covered most of it here, we're going to do a home tech tip that we're going to release. And so if you want to hear more about it, we go into a little more in depth on it. Not too much. I think it's 10 minutes maybe on that over at theaverageguy.tv. All right, well, as we bring this in for a landing, guys, thanks for coming out tonight on this Monday night. Christian alluded to it next Monday, or 2 Mondays from now, which is the 19th of January. We're on at 4 p.m. Central, 5 Eastern. We've moved up the time frame a little bit. I'll be doing it live from the Gallup Studios there for our guest. So if you just, I'll make note of that. I'll actually make that that show here in the next couple hours and put that out. Just if you want to get registered for it, you can. And 4 p.m. Central, 5 Eastern, January 19th for the next Cyber Frontier. So we will do it. We'll do it all over again. One quick reminder too: if you're purchasing on Amazon, we have a tech scholarship fund that we actually run through Home Gadget Geeks. Just a fun little way for you to support the network. And if folks want to buy and test out equipment, write about it, or come on the podcast about it, we buy that for them. You get to keep it, test it, review it. And actually, we purchase microphones for these guys and arms and that kind of stuff to help support the network through that tech scholarship fund. And if you're shopping in Amazon, go to Amazon, go to theaverageguy.tv/Amazon, and that will help support it. And many of you did over the Christmas holidays, and so we want to say thanks for doing that as well if you're a regular listener or user of that link. We'll be back in 2 weeks. I want to thank you for coming out tonight. Christian and Ashton, thanks for doing it. Appreciate it.
Yep, thank you.
And we'll see you guys in 2 weeks. Good night, everybody.
Good night.